Hello everybody. What we're going to be doing today is we're going to be going over what algebraic expressions are. It's kind of an introduction, or Unit 1, Lesson 1. So feel free to be taking notes as we go along. You don't have to write all these examples down, but make sure you're paying attention. So basically what we're going to be doing right now is figuring out, it says write an algebraic expression for each verbal description. So one of the things you have to understand is like, what is the word difference? What does that mean? All right, so when you're talking about the difference between something, you're dealing with subtraction. So we're going to find the difference between 10 and u. So it's going to be 10 minus u. Order is very important when you're looking at these sentences. When it says the difference between, or difference of 10 and u, you got to make sure you put the number up front and the variable at the end. Now this number right here is referred to as a constant. Okay, so I'm going to write constant. And this letter represents a number that we don't know. That's a variable. This represents the variable. Okay. Now, next one, number 2. It says 2 times the sum of 18 and a number. Well, I don't know what that number is, so you could use any letter to represent a number. It could be A, B, C, D. I'm just going to put X. That's very commonly what we use to represent a number that we don't know. All right, so it says 2 times the sum. So 2 times the sum of 18 and a number. So I'll put 18 plus x. That's the sum of 18 and a number. Now the cool thing about addition, it really didn't matter if I put the 18 up front, because when you're adding things, order really doesn't matter. When you're subtracting things, order does. So this is called the commutative property, to go from here to here. So what is the commutative property? A plus B equals B plus A. All right? So I'm going to go and spell commutative. Think of a commute. When people go and have a commute between work, that means they're traveling. Okay, so we're moving these numbers. The commutative property works with addition and multiplication. So I could say A times B equals B times A. So think of it this way. Ready? 2 times 3 equals 3 times 2. Just like 2 plus 3, which is 5, equals 3 plus 2. All right, so that's basically how easy it is. Now let's move on down here. We'll do a couple of more here. All right, just as some examples. All right, now if it says the product means multiply. So the product of 33 and j, that means we have to multiply 33 times j. Now when you multiply a number and a letter, that becomes combined as so. 33j. 33j means 33 times j. Now this number is what we refer to as a coefficient. A coefficient is a number that's in front of a variable or a letter. That's the coefficient. So the j is the variable, 33 is the coefficient. All right, let's do a little bit trickier one here. It says 3/4 the square of b. Like, what in the world is the square of b? So the square of b is written as b squared. Now if I take 3/4 of that, that means I'm multiplying 3/4 times b squared, which is called the square of b. So together, we put it all together, that becomes 3/4 b squared. All right, and that'd be your answer. Now what does 3/4 represent? That's the coefficient. The b represents a variable. So b squared, that's your b is the variable. 2/5, the cube of a number. Now the cube of a number, now you could use any letter. I'm just going to use A, just so you know, you can use A. I'm going to say A is the number. I don't know what it is, but A cubed, that means you're multiplying A times A times A. Just like over here, B squared is B times B, a number times itself. So if I do 2/5 of A cubed, that means I'm taking 2/5 and I'm multiplying it to A cubed. So that becomes 2/5 A cubed. Now you could also write it as 2A cubed divided by 5. Either way would be acceptable. I'll go and clean this up just a bit. All right? So either way is acceptable. So basically what we're doing is we're taking algebraic expressions for each verbal expression. Now we're going to go and we're going to write a verbal expression for each algebraic expression. Now some of them are easy. Like here we could just say this is 7 cubed, and you're done. You could say the product of 23 and f. So let's do a little more difficult one. Ooh, I like this one. So if you want to, you could write this one down. Right, 4d cubed minus 10. But we're not going to say 4d cubed minus 10. We're going to say, let's make it a little bit fancier, the difference between remember, there's when you're dealing with subtraction and division, order does matter. Okay, so we can't, the commutative property does not work with division and subtraction. The difference between 4 times a number cubed and 10. The difference between 4 times a number cubed, there's the number, our number just happens to be d, cubed, and 10. So technically you don't have to put d, you could just put a number because d represents the number that we don't know. All right, so now how would I write to the power of 4? Well, I kind of just gave it away there. That's how you write it, to the power of 4. So you could say a number cubed. All right, so what is the number cubed? X. X is number cubed. Times a different number. This is why you have to be specific, because x represents one number, y represents a totally different number. So we put a different number. Now you could say to the power of 4, but I'm just going to put raised to the power of 4. Because words are powerful. Of 4. Now I'm not going to go through all these, but basically I want you guys to understand certain words. All right, when you're dealing with adding, you're dealing with the word sum, and multiplying, product. If you're dealing with an answer to a division problem, you're going to be dealing with the word quotient. Okay, the quotient between things. All right, so those are some examples right there. Okay, so right here we'll do one more dealing with quotient. Okay, because you could actually write this two different ways. All right, you could say the quotient between, that's not a very good cue. Let's try it again. Still not very good, but that's okay. You can hopefully see it. The quotient between a number raised to the power of 5 So the quotient between a number raised to the power of 5 and 6. So the quotient between basically a number to the power of 5 and 6. Now, a quotient, you could also write it. Technically, you can't see it, but there's a 1 right there. That's 1k to the power of 5. So I could also technically write it as 1/6 of k to the power of 5. So instead of using it, calling it a quotient, I could actually say the product between 1/6 and k to the power of 5. Just like on this one, I could say 4/7, not fourth, my bad, 4/7. There we go, 4/7 of, because of means multiply, 4/7 of a number squared. A number squared. Okay, so 4/7 of a number squared. That's basically, now you could also say 4 times a number squared divided by 7. Or you could say the quotient between 4 times a number squared and 7. I'm not going to write all the sentences down, but that's what you could do. You could rewind and hear me say that again if you want to, or not. So those are examples of algebraic expressions. You got to be able to do two things, okay? You got to be able to take words and create an algebraic expression. And you got to be able to take a verbal expression, basically an algebraic expression, and create words out of it. So let's do one little word problem, and we'll call this a day. It says a used bookstore sells paperback fiction books in excellent condition for $2.50 and in fair condition for 50 cents. Write an expression for the cost of buying E, excellent condition paperback books, and F, fair condition paperback books. So that kind of gives you a hint right there. Right here it says E represents excellent books. And what do excellent books cost? They cost $2.50. But fair condition books, F, they cost 50 cents. So 50 cents per fair condition and $2.50 per excellent condition. So this was very easy. All we're going to do is put 2.5. We don't even have to use the 0 because that's really 2.5 and 2.50 are the exact same. Times E, which represents excellent books. That'd be the price of all the excellent books that you buy. What are we going to do? We're going to add fair condition books, which are 50 cents. 50 cents, so 0.5, 0.50, 0.5, same thing, times F. And voila. There's your algebraic expression to represent the word problem. And that's all you're going to be doing. All right, hope this video was helpful as you practice problems on your own.